In our previous video, we kind of got started with Bifrost and just looking at the basics of working with it. We worked with a very simplified torus primitive as our emitter, and we created a pool-sized sort of object here to hold our fluid. Let's continue on with the lesson and see what else we can do here in Bifrost and proper working methods and industry standard sort of procedures. So as I've said, I usually keep my resolution fairly low when I'm working with the simulation just to get the feel for it and to see how things are going to pan out. Once I'm satisfied with that, I'm generally going to up the resolution in the firm knowledge that it will slow things down and I'll have to take my time. So I'll come to the Bifrost liquid properties here. And I'm going to change the master voxel size from 0.2 to 0.1. Rewind. And let's take a look at our simulation now. So again, as we reduce voxel size, we are increasing both simulation accuracy, simulation detail, and simulation time. Sorry if I bang my microphone, it's going to make that noise. I apologize about that. Remember, I'm new to this whole YouTube tutorial thing. It'll all work out. Not too worried. So hopefully you can see the increased detail in our simulation here. And you can also probably note that the simulation is running much, much slower. And I'm running this on a 64-core processor, which means your simulations might run even slower than this. The good thing is, though, when we're running our final simulation, we're not sitting here watching it in real time. We're going to cache it to disk, kind of go to bed, wake up, make sure everything's okay. All right. So I'm going to pause the video for a second. I'm going to let this run and finish its fall into this container so that we can go on with the tutorial and you don't have to sit here and watch it the whole time. Okay, now I've let this simulation run for a little bit here, just so that it's gotten to this point. And one of the things I want to point out is that I don't want to always start my simulation, of course, falling from a great height. Perhaps I need my simulation to start right here. This is what fits my film or my animation or the visual project that I'm working on. So what we can do is when we get to a point that we like our starting mass, sort of like this, I'm going to select my Bifrost liquid and I am going to, under the Bifrost fluids menu, set the initial state. And it's going to create a file that basically copies this state right here and sets it as frame 1. So if I hit rewind as I've done here, you'll see that now everything stays in place and my simulation will begin at this point. Now, when I hit play, you'll notice the emitter will pop back up, and that's because we have to turn continuous emission off. So if I hit play, you'll see that, boom, there's our emitter again. I don't want that there, so what we're going to do is we're going to right-click. Remember, we set some keyframes up here. We're going to right-click, break this connection, and simply just turn continuous emission off. Rewind it again, and if I hit play, you'll notice that it doesn't reappear. And now I can just worry about my simulation filling this sort of pool-like structure. And that's how we do it. So I never want to have to just start my simulation each time. A lot of times I would like to get it exactly where it is. Now, that should be enough for this one, and we'll move on to part 3 in just a second.